Afternoon. My name is John Behnke. I'm the GM of INFICON IMS Group's Final Phase Systems, or FPS, product line. I'm pleased to be able to speak to you today about a couple of kind of broader topics here that I hope are somewhat insightful for you. Basically going to give an overview of smart manufacturing globally, definition, what does it mean, where does it entail, what do you need, particularly its status in semi. And I'm going to close with a little bit of insight into how COVID-19 could potentially accelerate the adoption of smart manufacturing even beyond its current relatively quick rate. As I mentioned, I'm part of the IMS group. That's INFICON software team, which is Intelligent Manufacturing Systems Group. We have two product lines. And my product line is the FPS product line. We decide when, how, and where to move inventory. Basically, we're the IE productivity, factory-wide optimization, digital twin, factory scheduling, etc. And we have a sister group, the Fab Guard group, which is more tool process monitoring, maintenance, health, EOCAP. So in general, it's really more centered on the individual tool as opposed to the entire factory. And we work together and all of our products integrate seamlessly. INFICON's global presence is reasonable. We're a mid-sized company. We have 1,244 employees. But the most important thing is that we are where semi is. So we're in North America, we're in Europe, and we're in Asia. And there is somebody, boots on the ground, very close to you at all times. And we're very excited about our emphasis in the last 18 months on really increasing our expertise and our centers of excellence in Southeast Asia and in Europe. Now, pivoting away from, who is INFICON, and first of all, I hope you already knew us. I want to talk a little bit, what is all this smart and Industry 4.0 stuff anyways? So, first of all, smart manufacturing is largely the North America, more Asian definition of the same thing as Europe's term for Industry 4.0. So the two terms are used very interchangeably now. They came about the same time, but out of two different think tanks relative to the same phenomena. And so I'm going to use those interchangeably. I tend to use smart more because I'm in North America, and SEMI has used the term smart, and I'm involved with them. But the reality is that both, consulting groups on both continents came up with roughly the same concept. And so effectively, the first industrial revolution was literally the weave, in 1784, the mechanical weaving loom. So it ironically was almost exactly 100 years later until the first assembly line in 1870. And once again, almost exactly 100 years later for the first PLC, or programmable logic controller. And so really from 1969 until a few years ago, maybe 4 years ago, was really the first programmable logic and what we would call the first phase of electronic industrialization. And most of us have grown up in that, the continuous improvement, lean, integrated systems, all of that was part of this 50 years approximately. And now the fourth generation, the fourth industrial revolution, or smart manufacturing, again, being interchangeable, is really upon us right now. And that's really when the cyber-physical production systems merge with real worlds, okay? So effectively, you're merging the real and virtual world such that the data is now so resolute and real-time and capable that it can emulate reality spontaneously to make decisions. So the way some folks define smart manufacturing, NIST usually does a good job of defining things, defines smart manufacturing as systems that are fully integrated, collaborative manufacturing systems that respond in real time to meet changing demands and conditions in the factory, in the supply network, and in the customer needs, okay? Another definition, a smart factory can be defined as a factory where a CPS, I'll talk about that, or digital twin communicate over the IoT and assist people and machines in the execution of their tasks, okay? Very similar. Another definition, which I do want to talk a little bit about, is a more recent one that Deloitte put out, another great consulting firm that's working heavily in this space. And what they say, I'm not going to read the whole thing, but the underlying part is they talk about smart factories are flexible systems that can optimize performance across a broader network of factory suppliers and partners, self-adapt to and learn from new conditions in near to real time, and autonomously run entire production processes. Now, I purposely underlined across a broader network of factory suppliers and partners. I don't want to argue with who wrote this from Deloitte, but my perspective is that's the end state vision. So certainly, eventually, we want to be able to have all connected from raw material start to system shipped in a box to your end client. Today, we're not there. And certainly, we use the term smart manufacturing really to refer to any physical operation of which you want to create a digital twin and have the ability to virtually replicate and emulate. And so that's an important distinction, because some people get hung up with, well, we can't do this yet because we don't have the protocol to speak to all 16 of my different factories, or I need this new communication methodology, or I need a new security system. Maybe true for the end vision, not true for just making your particular factory smart. Super important point. I'm going to spend a minute on cyber-physical systems and digital twins because they're so critical. People really don't use CPS much, a little bit in Europe still, but the CPS was a big word under the Industrial 4.0 terminology, where it's a cyber-physical system that they abbreviate CPS. Really, people have just gone to the digital twin, I think, because it's easier to say. I don't know. But they're the same thing. It's really the situation where you have aggregated and computational elements that have the ability to sense, control, understand, the physical and engineering systems, and they're all monitored. All operations are monitored, controlled, coordinated, and integrated to be able to make real-time adjustments with perturbations that are planned or unplanned. Tool goes down, it wasn't supposed to go down. Automatically adjusts, makes the best possible adjustments. Power is lost and obey. What is happening? All of the kinds of things that normally would take human beings, and quite frankly, pretty skilled human beings, should be able to be handled by this digital twin or CPS. And so it's really critical to understand that it's really a lot of communications, a lot of computation, and a lot of control. Ironically, it was really us in the semiconductor industry, by so dramatically lowering the cost of memory and lowering the cost of computation, that has really created these components that allow us to now have digital twins that can handle the computational requirement of a large modern semiconductor factory. Okay, so let's move away from what's smart and just kind of a little bit of mini tutorial and move to SEMI. So I don't think I said this, but I'm the co-chair of SEMI's North American Smart Manufacturing Committee. It's a great team. If you're not involved with SEMI Smart activities, I strongly suggest that you become involved. We have organizations in, I think, 7 different regions around the world. It's a very great organization. SEMI in general is a great organization, and their smart manufacturing effort is quite good. I stole this from one of our foils. It talks about the pillars for 2020. At the end of the day, the only reason anybody does smart manufacturing is ROI. Why do we invest in anything? And what I thought was done very well by Bobby Mitra, who's kind of the head of the North American group, is he broke down the foundational elements into sensing, connecting, and predicting. And so it's really quite interesting because you need sensors to be able to have information about what's happening now in this factory, this digital world. And in addition, you need connecting. I mean, connecting is really, sensing and connecting is kind of what we've been trying to do for the last 25 years. But now the connecting is getting much more powerful. A digital twin is mostly connecting, but it's connecting in a way that it's doing a tremendous amount of real-time computation and real-time learning. So it's not a static database like we're used to in our past. And likewise, other operational data stores, systems, facility systems, there's a lot of connecting that's required, because the holy grail here is predicting. Everybody is moving to the right. It's predicting this ability for us to have this factory that is virtually represented in a digital twin of itself, that is manipulating what people are doing and tools are doing and setups, configurations, etc., as a function of real-time perturbations and events. That's what everyone's after, okay? And there's a number of those. I put on here the items that are in blue, and the blue boxes are actually all products that are made or available from INFICON. INFICON's really, its mission right now is to be the premier smart manufacturing provider for semi industry globally. We're very excited about it. It's a lot of fun. The FPS group has only joined INFICON for about not quite 2 years. We were purchased by INFICON, and we're excited to be part of this migration. So the other thing I mentioned, we do this for ROI. Why else would we do it? Well, this is a great little presentation from another source, and that we saw in the semi group consulting firm. And what's interesting is here they're pointing out how the anticipated improvement from smart manufacturing activities, as opposed to the historical last 25 years of what we would call continuous improvement. So the rate of improvement under these categories like on-time delivery, quality, CapEx, logistics, labor, overall productivity are literally expected to be somewhere between 7 and 13 times the rate of improvement we've seen over the last 25 years in these next 5 years. And I absolutely believe that, and we see that. And I added this one little statement here, in that in semi in particular, I do not believe this would be true in all industries, but in semi, being the world's most complicated manufacturing process flow, with a very, very large number of reentrant tools, a very, very large number of different products, recipes, etc., scheduling is the single biggest enabler of these ROI returns. And we'll talk a little bit about that as we go through the presentation. So before we do that, I wanted to come back to digital twin a little bit as it pertains to semi. So a couple of points here. One, a lot of people who've been running fabs for 25 years, 30 years, like I have, it's like, well, we already have all this data. We have all these databases. I have this great YMS system. I have all these different systems, this great MES. Why would I need a digital twin? Well, the difference is you have a data-rich environment, which is largely a lot of databases that aren't directly connected, aren't learning, and aren't capable of actually performing like a digital twin. It's a lot of great information and data, but it's not a digital twin. That's really important, okay? So the current digital twins, we'll talk about kind of where digital twins in the semiconductor space are today and where they're going. The current ones are, as I mentioned earlier, predictive learning, comprehensive, data-rich emulators of your factory. There are a few of them available, and they're super powerful. In general, they integrate all the various subsystems and data sources above, and they actually have many different connections to other large data systems, but they're not one database. There's a misnomer that you need a huge data lake, that's going to be your digital twin, or you need, I only want to have one database to run everything. Both of those are incorrect. What you really need is a smart, comprehensive digital twin engine that has the ability to connect to and ask for and receive pertinent information that it needs relative to its execution time frame for making an adjustment. So it doesn't need to know a yield correlation that's not going to change every second. It does need to know, well, which tools have the best defectivity rate right now. So the SPC system has to be able to tell your digital twin that. But it doesn't need to know the correlation that may be a back-end yield real time, because that's more of a longer term change. In general, predictive aspect of digital twin is really completely changing everything we're doing. It's actually very exciting to be involved in this part of the business right now. The initial focus has been completely on ROI. I mentioned that earlier. Really, scheduling has been used to just dramatically improve output. It's not unusual to get 15% more capacity out of a factory, could be 20. Cycle time and on-time delivery are probably two of the biggest influences, because the inefficiencies that are wrung out with a really great scheduler are things like queue times and waiting and so forth, and linearity is dramatically improved. On-time delivery improves dramatically. So that's a really important thing to know. And of course, equipment health and maintenance and yield correlations. So the thing I will say that is most recent in the area of digital twins, and in this particular case, I think we're the only ones that are doing this, we've been INFICON, is pivoting from purely operational efficiency and moving into quality. Some of our leading customers are automotive manufacturers, and as we worked with them to improve their productivity of their factories amazingly, they said, well, look, this is great. We need help improving our quality. And working with a couple of them, we've developed a product that basically manages sampling. And it manages sampling like it's never been done before, completely and totally holistically integrated with the digital twin, so that it's intelligently deciding what you should test, what your risk is, what your exposure, and of course, it literally modulates itself as a function of real-time monitored defectivity rates, et cetera. So pretty exciting application. Please, we have another talk that Dave Weiselman gives on our on-demand site. You should see that. It's a pretty exciting product. So beyond that, going future, we're going to actually see more and more things that occur as people just start to think about, what can I do when I can predict the future, right? And so you're going to see really integration of these mini digital twins, particularly around specific tools to improve smart predictive maintenance and to do a better job of actually leveraging the maintenance activities, the needs with your WIP condition, your inventory condition, your availability of people, staff, parts, etc. So it's going to be integrating with individuals, humans, and probably originally with either direct labor if you have a 200 millimeter factory or a back end, and then of course a maintenance staff if you have a 300 millimeter automatic factory. But a lot of extension here as the digital twin touches more people throughout the organization. And then of course, ultimately, we're going to go across the entire supply chain. So we're going to go into it more fidelity, and we're going to go across to get more of the actual production sequence. This is just an earlier graphic from our semi team. I don't think we use it anymore, but I like it. And it just points out that in the middle really is the fab. And in semi, that's really where most things start because it's still the most expensive part. I've shown here that, we believe FPS has probably the most comprehensive digital twin for a fab in the world. And then the Fab Guard, I gave an example here how if you make a very extensive model of a tool and what it does with sensors, monitors, FTC, health, etc., that's a mini digital twin of that process. And then the summary data from that gets connected up to the larger operational digital twin. And today we're deploying in the back end with some of our leading clients. And eventually, of course, then you connect the front end to the back end such that we can real time modulate the demand and speed of which we're moving material through the later stages of the front end in order to keep the back end flowing well. And that's where I see the first really next step of this integration as we go towards the path of an integrated holistic digital twin across the entire supply chain. This is just a simple view to remind me to say that it's not just the level 100 or the we call it a tool level of the fab that is being addressed. More and more today as we go into the Go Green. The Go Green initiative is a great initiative if you haven't been involved with that under Semi Smart Initiative. But in general, people are saying, let's not just look at the tool floor. Let's look at what's happening in the subfloor with the pumps and the abatement, and the chillers, etc. Let's look in the attic where the abatement systems are, such that all of these systems can be connected to the digital twin and monitored and controlled so that you don't need a tool for as little as an hour and a half. It's not going to be required by the scheduler. Put it in green mode, save the energy, save the consumption of consumables, be it an abatement gas of some type. So all of that is coming. It's coming very quickly. It's pretty exciting. And this is just meant to be try to put a little bit of graphic here. It's kind of an architectural view, somewhat INFICON centric, but not too much. The middle is your factory. So it could be a little different if you're an older 200 millimeter factory, you've got carts, so you have people, you might have a barcode reader. If you're a very modern 300 millimeter factory, everything's direct load, directly to the tool, so you don't have operators or carts. In general, you still have WIP movement, okay? You need to know where the WIP is, and you need to move it from point A to B in the appropriate sequence, etc. And you still have an MES, everybody has an RMS, SPC, etc. So these middle sections are everybody has them, they just look and feel a little different depending upon your size and really candidly the age of your factory. So the beauty of the INFICON solutions are they're agnostic to all of those systems. We've connected to more than 13 different MES systems. And so the digital twin on the left-hand side, which is part of the FPS solution, runs all of its applications. And then it is connected to the executive and the Fab Guard IPM systems that manage the tool health. And they're all connected. So the most important thing is, it doesn't matter how old your MES is or what type it is, we'll connect to it and turn it basically kind of a picture into, sorry, how does that go? Sow's into a silk purse, I think is a saying. And that way we'll end up taking your old system and turn it into a brand new looking system through the front end GUI of our dashboards and other applications. We've done that many times. It's a very successful model. Which kind of brings me to this little sides conversation here. A lot of interesting, solution provider hype about smart, and any of you who own fabs or run fabs are getting hit left and right from everybody. I can only say that getting a new MES does not make you a smart fab. You may need a new MES. You may not. Certainly, the older MESs, the Promise, the Workstream, etc. We have many clients that use them, and they work great. Okay, particularly if you add a smart layer on top of it, such that the custom stuff you had built previously largely gets taken over. And so, you may have a reason where you just feel like you have to get a new MES. But in general, our experience has been that you're far better off just putting a smart layer on top of your MES. So it can do all the heavy lifting, the smart integration, because MES, even if you go get a new one, it takes you a couple of years and millions of dollars, and it still won't be smart. And you've lost 2 years typically in the timeline to getting the ROI, which is really going to become very critical from the point of view of competitiveness. So basically, our attitude is any MES can support, smart deployment. And then I guess our other comment would be that if you really do need an MES, then we should talk, because many people we see deploy an MES, largely trying a new MES, trying to emulate or copy their old MES, but in a new structure, and then it's not very well suited structurally to be able to integrate with a smart digital twin. So we've come into factories that have just completed complete conversions to new MESs. We've had to almost start over and redo the MES setup and installation, because it wasn't configured in a manner that is appropriate for the requirements of a digital twin. So in general, our attitude is do a digital twin. It's certainly not hard for us and most really good digital twins to be able to go to another MES as a data source if in the future you felt you needed another MES. But the point is understand the structure and the requirements. And you can read this later because this is downloadable, but these are kind of our discussion points. Quickly, I just wanted to point out that, the FPS product line, we have the digital twin dashboard, which is basically the incredibly complicated and powerful visualization tool, real-time drill down, factory scheduling, we mentioned it. We have a next move that's important because scheduling is great, but if you don't actually have the ability to go from this generated schedule of where I want everything, and then to be able to translate and connect to whether it's your AMHS system, your robots on the floor, your carts, your operators, to actually ensure that those directions that the digital twin and the scheduler have created through its optimization algorithms aren't followed, you won't get the ROI. So that's a whole application that we have. I think we're the only ones with that, but it's important. MSO I talked about earlier, and we have a whole slew of basically analysis tools, because when you have all this data, you can really do some deep dive analysis to determine where your opportunities are. I felt kind of obliged to at least show you a scheduler. It's a very simple version, but it's an example. If you want to see that, please go see Matt's talk on download Matt's talk. It's very good. This is just my earlier comment about MSO. This is, we are actually announcing MSO formally as part of SemiCon West this year. We're super excited about it. We'll have 7 or 8 fabs up and using it already by the end of this year. And I'm sure we'll probably have 20 or 25 by the end of next year. It's a one-of-a-kind product that's pretty exciting. And then Fab Guard is our sister group. I mentioned that. And they really have FTC, Fab Recover, Fab Control. In the area of fault detection and classification, we have Fab Guard deploying machine learning and artificial intelligence to be able to make what we refer to as kind of smart FTC, to reduce the labor burden of establishing the actual kind of rules and setup associated with creating an FTC system. I'm pretty excited about that. Fab Recover is one of our newer thrusts this year. We've worked with a couple partners in the semi industry. This is basically going beyond FTC and actually going, okay, so I've done a maintenance event. Did it work? Did it not work? What part of it worked? How do I create this over time into a virtual BKM such that I have this repository that, particularly in our industry, as some of the really greatest maintenance technicians are retiring soon, we want to be able to have a digital repository of their expertise and be able to help first-time success on things like that. So this is an exciting product. Last spoil, and I promised you that I would talk a little bit about COVID-19 and its impact on generally fabs and smart deployments, and I guess more broadly, I would just say worldwide manufacturing. And so what happened was when COVID hit, executive level folks, I'm talking mostly C-suite folks, got surprised that their factories were not as autonomous or not as automated as they had thought they were. So you would take a factory and say, well, you can run with 50% of your staff because maybe you had to have the other half off because of local regulations relative to COVID staffing, et cetera. And rather than getting 50 or 70% of the expected output, you'd get 20%. Well, there was little understanding of just the dependence on operators, 20-year operators to make decisions, supervisors, et cetera, basically the manual intervention. And as a result, linearity got messed up, bubbles created. So just a real big impact there. And then of course, the other thing is today in all factories, there really isn't a good system to trace operators. Us and other folks, I'm sure, are working on adding that to the digital twin so that in the event that you did have somebody who was impacted by COVID-19 or whatever comes down next, you could say, well, Mary only worked on these 3 tools on her shift and only came in contact with these 6 people. So it's really 6 people that we have to take and send through for 14-day quarantine and not the shift. So those are kinds of things that don't exist today and would have helped us. The other big deal is that critical engineering, it's unbelievable how lack of real-time reports and analysis systems are available. And so it makes it very difficult for the virtual engineer. Many of us are working from home who are kind of white-collar workers, et cetera. But engineers are used to being near the fab, et cetera. And having a digital twin and the visualization, if you don't have that, you're at a very significant disadvantage. I will say that probably one of the biggest things that an excellent digital twin does, certainly ours does, is it deals with linearity. And basically what I mean by that is it deals with whip bubbles. Most factories deal with that the best they can through supervisors, et cetera. But in the middle of the COVID, that got much worse. So not having a supervisor all the time, not having the ability to bring in a supplier, a tool vendor to come in and fix a tool that was broken, and maybe the policy said he's coming from the US, so he can't come in my fab. And so all of those things cause for much more entropy and confusion and therefore higher whip bubbles, which really leads to worse productivity. A good digital twin manages whip bubbles no matter where they are, whether they're on a constraint tool or a secondary constraint tool. And that's just very, very difficult, nearly impossible, candidly, for human beings to do. Of course, this rapidly changing product demands, which is happening as the COVID thing changes what people need or don't need, is also something that's very difficult to do by a human being, particularly when you're planning, people are working remotely, et cetera, whereas a digital twin can do that and assist with that quite easily. So in general, I would say that, and there's some other items here like clearer fab prioritization, which is hard to see when you have a limited staff. But in general, I would just say that COVID-19 is brought out, illustrated to folks that they really need a smart factory. And what I would suggest to you is you leverage that with your executive team to get the funding to do it. Because as I said earlier, it's completely and totally available to you today for any fab in the world. You don't need a new security protocol. We don't need a lot of the things that we may need to be able to go across the entire supply chain, but to turn your factory into a 15 to 20% better factory and a dramatically improved on-time delivery, et cetera, all that's available today. Interestingly enough, I read in a paper that this phenomenon here of this COVID-19 effect, there was an article that said they expect literally the next 5 years of planned investments in smart deployments to be pulled into the next 18 months because of this realization. So I guess my comment would be, get started, certainly talk to the right people, and thank you very much for your time. I guess the last thing I'll say, of course, is please stop by our virtual booth. We have quite a few, I think, very good chats and talks, et cetera, and we're here to talk to you at any time. Again, thank you and have a pleasant day.